Hello, everyone. Today, we want to initiate a series of videos that we will talk about the fundamental meanings and the concepts of statistical approaches and data mining processes in water resource planning and management. So for the first session, we decided to talk about the time series. So what is the time series? The time series have different meanings when you consider the most fundamental meaning of the mathematical word series. You have already known that the mathematical series are some kind of statements that are gathered together, and there is a consecutive similarity between them. Let's talk about some samples giving in here. So in here, we are continuously having some kinds of statements added to the previous ones, or a set of, let's say, odd numbers or even numbers that have a certain amount of values or definition between each other, but all of them can be recognized by the separation of the specific amount or value that are added or separate each of these statements or the values from each other. Let's say we got one value, now one, and after that we want to add, let's say, 0.5 to it, so that this will be the next value of this series. And if we continue to do that, you can say that the 1, 1.5, 2.0, 2.5, 3, and this ensemble of values generates a series, a mathematical series, with each value has about 0 point value difference between the previous value. But in physics, let's move slowly and talk about the concept of time first. So we have values that are separated with a certain definition. Here it is value as 0.5. If you consider time as the separating value for the measurements of a certainty in time in a location, let's say, you would have a time series. Let's say if you are measuring the temperature of let's say a metal in the lab, in the beginning, let's say we have T here, and we have the temperature, the time, and the temperature. When in the starting point, the temperature, let's say, is 1.5, and 1 second later it becomes 1.76. And let's say, what did we say in the previous section? We said that there must be a stable and one separating criteria between the values. So if we want to generate a time series, we have to decide on the time interval as the separation. So here's between two values, there is only 1 second, if it is in seconds. You can also select them in days, time, hours, years, decades, etc. So here we select it as second. So 2 seconds, around 1 second later, it will become 2.22, let's say. 1 second later, it will become, let's say, 4.1, and afterward, it will drop or have a decrease. It will experience a decrease. Let's say it will suddenly become 0.36, and in the fifth second, it will become negative, let's say. So here is a time series, but why? What's the definition? Because the definition is that the time interval between the measurements are set to be a time, 1 second. When you consider the time in physics, it has more sophisticated meaning in time and space, and already there are some articles written in the literature that time is considered to be two-dimensional entity. So here we are talking about a mathematical and engineering realization of time. If you and this, what do we mean by this? We mean here the changes, the measurement of the changes. Let's say changes in state of an object. Let's have it simplistic. Animated GIF file. Let's search for those. So let's talk about this one. Consider this is our working domain. So this is ever changing, isn't it? So what do we do when we want to generate a time series? Actually, we are measuring it in different times. And when we are measuring it, we want to know that we want to learn about the different values that this domain takes during the period that we are studying it. So here is the time series, and the time concept here is the amount of changes that can be recorded in a location or an object or anything during a certain period. So here is the meaning of the time series. In hydrology, we are dealing with many types of time series. Stream flow time series, precipitation, evaporation, groundwater, lake water depth, velocity, acceleration, anything. And even if you consider engineering concept in general, you may have a look at the momentum, at the reaction timing, and etc. So here are some samples about the time series. These are given in monthly format. So any value here are recorded each month as an average, total, or anything you can say. In here, if you can say, you see here that it is in the 10th or the October of 1974, the value of the stream flow discharge is 44.6, and the next month average value is 52.2. And the same can be said for the precipitation, evaporation, groundwater, and lake depth, all of which are recorded at the monthly time scale. Maybe in the future we will talk about the daily or hourly or secondly recorded time series, as the application may be different and some sorts of information can be driven from. In the next video, we will talk about the properties of the time series, the basic properties of the time series, and I will try to also talk about the advanced properties of the time series in the future videos. So to keep it short, I want to end this, and we will see you soon in the future videos. Thank you. Bye bye.